Welcome to this section on Git. In this section titled Introduction to Git, let's get an introduction to some of the most important features of Git. We will start with talking about why is version control essential. There are a couple of architectural decisions that were made with Git that are very important, I think, for the popularity of Git. Number one, the fact that Git is a distributed version control system. We will compare what is distributed version control system versus what is a centralized version control system and see what are the advantages that distributed version control systems provide. And we'll also talk about something called a snapshot system that Git follows. For every commit you make, Git takes a snapshot. What does this enable? We will start with discussing these two in depth. After that, we will look at a short history of Git. And after that, we will look at a few of the popular version control systems before Git. Now, if you'd want to create a Git repo and work on it with your team, that's when you'd want to create a remote repo. GitHub is one of the tools that enables you to create a remote repository. It also provides a lot of additional features. That's what we'll be talking about in what is GitHub. Next, we will look at a practical example of creating a new Git repo locally and then pushing it out to a repository which is created on GitHub. So we will create a local repo and push the code out to a remote repo. And after that, we will get a deep dive into how Git organizes and stores your code. Git follows a layered approach. You have a working directory, you have an index or a staging area, and then you have a local repo or a local object database. And then you have a remote repo or the remote object database. We will talk about this architecture in a little bit depth, and we will see what are the advantages of having a layered structure like this. And after that, we will look at how a file moves through Git. Whenever you have a file, it goes through multiple stages before it goes from the working directory where you're working on it to the remote repo. So we'll be looking at all the stages that a file goes through in this specific step, how a file moves through Git. And at the end, we'll be looking at what happens in the background when you commit code. I'm sure this will be a very interesting section on Git. I'm sure you'll have a great time. I will see you in the next step with why is version control essential. I will see you in the next step. In this step, let's talk about why version control is essential. Let's start with what is version control. Version control system is a tool that tracks changes to files over a period of time. Whenever you are developing a piece of software, you would see that your code would keep changing over a period of time. Most teams have a number of developers and they would be working on these files over a period of time. You would see that typically the same file would be updated by hundreds of developers. And that's why you would need a version control system. It's a tool that tracks changes to files over a period of time. This allows developers to manage code efficiently and, more importantly, collaborate with other developers without having any conflicts. The purpose is to ensure that code history is maintained and developers can work together without overwriting other developers' work. So why is it essential? Number one is collaboration. Multiple developers can work on the same project without overwriting each other's work. Number two, history tracking. Easily view, compare, and restore previous versions of code. If I would want to be able to access the code as it was a year back, I'd be able to do that if I have version control in place. Number three, branching. We have multiple environments and we would want to make multiple releases. And therefore, you'd want to be able to create multiple branches for your application code. This would enable different people to work on different branches and work simultaneously. In this quick step, we talked about why version control is essential. I will see you in the next step. In this step, let's talk about how does Git distributed version control improve collaboration and efficiency. There are two types of version control systems. One is centralized version control systems. The other one is distributed version control systems. What is the difference between them? In centralized version control systems, a single central server stores all versions of code. Whenever developer checks out code, you are checking out a snapshot of what the current version of the code is. You will not be checking out the entire history. However, when it comes to DVCS or distributed version control systems, every developer has a complete copy of the repository. If you are checking out code from a Git repo, you would get not only the current version, but also you would get a complete copy of the repository, including history. Now you might be wondering, hey Ranga, what is the advantage of doing that? Why is Git built as a distributed version control system? What are the advantages? Let's compare between centralized version control systems and distributed version control systems. In a centralized version control system, you have single central server which stores everything. On the distributed version control system, whenever somebody makes a clone or a copy of the specific repository, each developer has a complete copy. So everyone who makes a clone or a copy of the repository has the complete copy. In the case of a centralized version control system, working offline is limited. You'll not be able to check history and things like that. You'll be able to get a copy and work on it, but you'll not be able to see branches, check history, and do things like that. However, in a distributed version control system, working offline is fully supported. In centralized version control systems, the server becomes a single point of failure, and that's why it needs to be backed up. However, in a distributed version control, each clone, any developer who's cloning a repo has the entire copy of that specific repository. So the server is not a single point of failure, and every clone, every copy serves as a backup. When it comes to centralized version control system, almost anything that you would want to do with history, branching, or anything else, it's network dependent. So you will be talking to the server over the network. So the performance might be little slow. However, in the case of distributed version control system, you can do a lot of operations locally. So the performance of your operations would be much faster. So how does Git's distributed version control improve collaboration and efficiency? It does it by having complete history for everyone. Every developer's local copy includes full project history, and this makes working offline possible. Your local copy includes all branches. Local clones contain all remote branches that were fetched, allowing developers to switch, create, or merge branches offline. You'll be able to do a lot of your work offline. And this would enable faster operations because most Git commands like commit, diff, these are local. These provide fast performance. And there is no single point of failure. If the main server goes down, any local copy can be used to restore the project. In this specific step, we looked at the fact that Git makes use of something called distributed version control. We talked about some of the advantages of Git because it's a distributed version control system. Let's dig deeper into some of the other characteristics of Git in the next few steps. I will see you in the next step. In this step, let's talk about why Git Snapshot system is a game changer. Before we talk about this, let's first understand what is a snapshot based system. Git captures the entire state of your project at each commit. Whenever you are making a commit, Git captures the entire state of your project, and therefore whenever you would want, you can easily get the project as it was at that particular commit. Git does not need to do any calculations or things like that. It can directly get it from the snapshot. It's like a photograph that Git takes and has for every commit. Instead of storing just the changes, instead of storing just the deltas, Git stores a complete version of changed project files. Even if you are making a few lines of changes, Git would store the complete version of the changed project files. One important thing to remember is that Git will not be storing the file as is. It will actually compress the file and store it. It uses its own internal representation. But the key thing is that it stores a complete version of changed project files. It's not storing deltas. It's not storing just what changed. It's storing the complete version. If a file is unchanged during the commit, then they are linked to previous versions rather than being duplicated. So if you have 10 files and only one file is changing during the commit, the other files will be linking to their previous versions. New version will be stored only for the changed file. What we are talking about is the fact that Git uses a snapshot based system. At each commit, Git captures the entire state of your project efficiently. Now, how is this different from delta based systems? In delta-based storage, only the differences between file versions is stored during commits. And this would mean more processing to reconstruct previous versions. For example, if I would want to get a specific version, you need to go to the base version and slowly see what are the changes, apply the changes, and only then you will get the previous version. So there is a lot of complex processing involved. And another thing is branching becomes really complex. Because changes are applied sequentially, branching becomes really complex. Let's look at an example. Right? If you have a snapshot based system, let's say I'm creating a new file and storing it. I'm doing a commit. Git would store the complete snapshot. And let's say you're making a change. From version 1, you're changing it to version 2. And then doing a commit. Git would store the new full snapshot of the modified file. And the same thing happens even if you commit it again. You make another change and commit it. Git stores yet another full snapshot of the file. So if you want to get this version, for example, if you want to get the code at this commit to, Git already has a full snapshot. So it will be directly able to retrieve. It does not need to do any calculations. However, in a delta-based system, let's say I have this file. SVN, when you create the file, will be storing the complete file for the initial version. Let's say I make the change from version 1 to version 2. SVN stores only the delta. SVN would store only the difference from version 1. So it will store the fact that line 2 is changed to version 2. For commit 3, let's say during the next commit, it would store that line 1 is changed to hello and line 2 is changed to version 3. Actually, over here, we made 2 changes. So in commit 3, we had 2 line changes. Welcome was changed to hello and version 2 was changed to version 3. So it does not make a difference to Git because it would store everything. However, for SVN, Subversion is one of the examples of version control systems which uses a delta-based system. So Subversion would store it as a set of changes. So it only stores the differences from previous version. So if you want to be able to retrieve an older copy, however, if you want to get code from an older commit, SVN would struggle a little bit because it would need to compute the changes. And typically in a version control system, you will not just have one file, you will have thousands of files. And that makes it time consuming. The calculations that SVN needs to perform are time consuming. So why is Git's snapshot system a game changer? Because of speed. You'll be able to quickly access any commit without calculating changes. And you can access it directly on your local machine because everything is stored on your local machine. Reliability. Because full file versions are always available. It does not need to do any calculations. And simplified merging. Merging is faster because complete versions are available. It just needs to merge the 2 versions which are completely available. It does not need to do any calculations in the background. In this specific step, we understood what is a snapshot system and why Git's snapshot system is a game changer. I will see you in the next step. In this specific step, let's talk about the history of Git. In 2005, Linux kernel development team required a powerful distributed version control system. So they wanted a version control system which allowed developers to work locally. The problem they had was that they were using a proprietary tool that was expensive, unreliable, and centralized. And Linus Torvalds, the creator of Linux, was the one who built Git to solve these problems. Git is really popular because of its three key design principles. One is speed. For any version control system, being fast is essential. A developer would be working with the version control system day in, day out. And that's why speed is a key differentiator. Git was designed to be fast even for large projects. Security is very important as well. You want every change to be tracked and verifiable. Next is decentralization. You'd want to be able to work independently, offline, without needing network connectivity all the time. Whenever you'd want to put your code changes live, whenever you'd want to commit it to a central server, you can do that. But you'd want to be able to do most of the other work independently, even in places where you do not have a network. So these were the three key design principles of Git: speed, security, and decentralization. And I think these are the three reasons why Git is so popular. In 2005, Git was released as an open source project. And in 2008 was when GitHub was launched. It made Git widely accessible for collaborative projects online. Git is a version control tool. Now, what is GitHub? GitHub is a cloud-based platform. It is used for hosting and managing Git repositories. So if you want to make use of a Git repository and you want to be able to have a team that works on this specific Git repository, you can create a repository on GitHub and you have your team configured, and multiple team members can make use of the Git repository which is hosted on GitHub. So Git is the software and GitHub makes it accessible on the cloud. And in the 2010s is when Git adoption surged as a number of open source communities and companies shifted away from Subversion or SVN. I had a lot of experience working with Subversion and CVS before that, and these were not so easy to use. We had a lot of challenges, and even the enterprises I worked with started migrating from Subversion or CVS to Git. And in 2018, Microsoft acquired GitHub. And this boosted Git's presence in the enterprise market. Today, Git is the golden standard for version control in software development. Git is what I have been using for almost every software project that I have worked in for the last 10-15 years. Now, if you want to use Git with a team, GitHub is not the only option. There are a lot of other options as well. GitLab, Bitbucket, Azure Repos, AWS Code Commit, cloud source repositories. All these are options you can make use of to work with a team on a Git repository. If you look at most of these tools, they not only provide you with a Git repo, but they also enable issue tracking, they'll enable project management, and they'll also enable continuous integration and continuous deployment. So they provide a lot of other features other than being a cloud-based Git repository providers. So GitHub provides hosted Git repositories with collaboration, issue tracking, CI/CD, and security tools. And you'd see that GitLab also provides something very similar. It provides integrated DevOps lifecycle tools, CI/CD, container registry, monitoring. Bitbucket is by Atlassian. So it provides very good integration with Atlassian products like Jira and Trello. Azure Repos, AWS Code Commit, and cloud source repositories are great to use if you're making use of that specific cloud platform. These are cloud-based services. Azure Repos integrates really well with Azure and Azure DevOps. AWS Code Commit integrates really well with AWS and all the tools in AWS. And cloud source repositories is Google Cloud's Git compatible source control service. So it has really good integration with all the tools in Google Cloud. So if you are making use of Google Cloud to deploy your projects, then CSR or cloud source repositories is a great choice. In this quick step, we got a short history of Git. I'm sure you're having a great time, and I'll see you in the next step. In this specific step, let's look at some of the popular version control systems before Git. Important version control systems before Git. CVS, Concurrent Versions System. This was a centralized version control system. This is simple and lightweight. However, it provided limited merge support, and this was prone to errors in large projects. This was used by early open source projects, but very rarely used these days. Next is Subversion. Subversion is also centralized. It is user-friendly with basic features. Especially the UI of Subversion is really simple to use. However, the weakness is that it's network dependent for most operations. And similar to CVS, even for Subversion, performance degrades with large repositories or with many branches. It was a popular choice for corporate projects earlier. I had a lot of experience working with CVS and Subversion early in my career. Next is Perforce. Perforce is also a centralized version control system. The differentiator for Perforce is that it's excellent with large code bases and especially great with binary files, large binary files. If you're talking about gaming applications, you have a lot of art and you have a lot of large assets that are stored. And for these kind of use cases, Perforce does a great job. Perforce has a complex setup and it's resource intensive, but it offers great performance for large code bases and binary files. And that's why it's still commonly used in game development. So a lot of game development projects make use of Perforce as their version control system. So until now we talked about CVS, Subversion and Perforce. And let's quickly compare Git versus one of the earlier alternatives that we talked about, Subversion. So Git is a distributed version control system. Subversion is centralized. In Git, the commit model is snapshots. Git takes a snapshot of the entire repository for every commit. So for every commit, you'll be able to get the code at that particular point in time very easily. However, Subversion uses deltas. That means if I would want to check out a specific commit, Subversion has to do a lot of calculation and then it would be able to give me all the files. Git fully supports offline work. However, in the case of Subversion, it's limited. Merging in the case of Git is fast and efficient. However, with Subversion, it can be slow. Branching is also lightweight and fast with Git. However, in Subversion, branching is slow. Git today is used by most enterprise and open source projects. And Subversion, the usage has gone down drastically and it's used by a few legacy enterprise projects only today. In this quick step, we looked at some of the popular version control systems before Git. I will see you in the next step. In this step, let's talk about what is GitHub. GitHub is a platform built on top of Git. GitHub is a web-based platform built on top of Git. If you want to make use of a Git repository for your team, you can go to GitHub, you can create a shared repository for your team, and your entire team can make use of the shared repository because of GitHub. So GitHub builds on top of Git and enhances what Git can do by adding collaboration and project management features. It is designed to host Git repositories. It provides a lot of powerful tools for team collaboration, code review, and project tracking. The way I would think of GitHub is Git++. Git in the cloud with a lot of additional collaboration and project management features. It is open source friendly. A lot of open source projects host their code on GitHub. This helps them to connect with the global developer community. When you're making use of GitHub, you can either create public repositories or private repositories. If you'd want your code to be private, only your team members should be able to see and do things on your code. Then you can go with a private repository. However, if you'd want your code to be open to everybody and you'd want everybody to be able to contribute to your code, Then you can go with a public repository. So you can choose between public repositories for sharing with the world or private repos for secure, team-only collaboration. GitHub offers a great user interface. It's very, very easy to use even for beginners. And GitHub adds features like pull requests. So you can create a pull request and ask for a code review. This would enable developers to ask for code reviews and collaborate through peer reviews before the code is merged into the main branches. GitHub also offers built-in issue tracking. Whenever we build code, there will be bugs, there will be enhancement requests, and there will be a lot of tasks that you would want to do. Instead of having a separate piece of software to have that information, you can put all that information in GitHub itself. You can make use of issue tracking in GitHub to manage your bugs, feature requests, tasks, and everything. And instead of having a separate space for discussion, you can use the discussions tab as a dedicated space for questions, ideas, decisions, all in one place. GitHub also provides CI/CD, continuous integration and continuous deployment, through GitHub Actions. So if you are making use of GitHub, your code is on GitHub, you can probably create a Docker image and push it to one of the cloud platforms directly using GitHub Actions. So you can set up workflows to automatically build, test, and deploy your code whenever your changes are pushed. Whenever a code is changed and it's pushed onto a GitHub repo, you can trigger GitHub Actions workflows, and these workflows would do all the actions you would want to perform. For example, test the code, maybe run a static code analyzer, and then you'd want to build a jar file, or maybe you'd want to build a Docker image, and then you'd want to push it out somewhere and deploy it on a cloud platform. All that can be done through GitHub Actions. And you can also host static websites directly from your repository. So if you have a portfolio website, or if you have some documentation or demos for your specific product you're building, you can have all that hosted in GitHub, and you can use GitHub Pages to expose it as a website as well. As you can see in here, GitHub offers a lot of features on top of Git. Now let's quickly compare Git versus GitHub. Git is just version control, right? It provides distributed version control. So you can have your own local repository, and you have the share code in a remote repository that can be hosted on GitHub. GitHub is cloud-based platforms for hosting Git repositories. This enables your team members to access the code and collaborate. Git does not have any project management tools built in. However, GitHub has issue tracking, you have milestones, project boards, and a lot of other project management features. If you want to add CI/CD to Git, you need a lot of manual setup. However, it's built in into GitHub. And when you're making use of Git on your local machine, it's difficult to get community interaction. However, it's very, very easy if you'd want community engagement through GitHub. If you just make your repo public, others would be able to look at your code, and they can star your repo, or they can fork and contribute to your repo, or participate in the discussions as well. In this specific step, we focused on what is GitHub and what are some of the additional features it offers on top of Git. Starting the next steps, let's focus on Git. Our main focus area in this specific section is Git. So let's get back to Git, starting the next step. I will see you in the next step. Hello, this is Ranga from In 28 Minutes. Do you know, we have almost 2 million learners learning from our courses on Udemy. And another thing you might not know, interview questions you have watched until now are from a course called Cloud and DevOps Interview Guide. With over 300 questions, it is the best cloud and interview guide in the world. Why am I so confident? First of all, we cover a wide range of topics. We cover 3 cloud platforms: AWS, Azure, and Google Cloud. And we also cover a wide range of DevOps tools: Git, GitHub, Docker, Kubernetes, Terraform, and beyond. Our goal is to continuously update the course as the DevOps space evolves. Check out the full course using the link below. We added in a special discount for our YouTube learners in the link. So do check the link out. And there's even more. We are giving away free access to the course every month to 100 lucky learners across YouTube. Here's how you can win. Just post a detailed review of the video on LinkedIn, sharing what you have learned in the video. And don't forget to tag in 28 minutes and also me, Ranga Karnam. Thanks for watching and happy learning. Until I see you again, here's bye from Ranga at in 28 minutes.